Section. So how we can do it? Just go to this mesh. Okay, if I go to this mesh, okay, and if I click this, and if I just press right button, and if I generate the mesh, see how the geometry look like. Now it has been divided into small sectors, number of different small sectors. Okay, and then once this meshing is done, now I need to define the boundary conditions. Okay, now I need to define the boundary conditions. Okay, so how we are going to define the boundary conditions? See, when you click this static structural with the right side of your mouse, see there are different insert option is there. Okay, in this insert option I need to define a fixed support at one end. Okay, so now I'm going to define the fixed support at one end. So I want that this section should be a fixed end. So how I'm going to do it? See, I'm just rotating it. I'm going to select the face. See, these are the different options for selecting. Either you want to select a vertex, you want to select an edge, or you want to select an face, or you want to select a body. Okay, all sort of options are available in this geometry. Okay, I want to select this face, this complete face, for providing a fixed support. Okay, so now I have selected this face. Now if I select this face, just hold on for a second. Okay, if I remove the cross section, vertex. Okay, just hold on for a minute. So this was the meshing. Okay, and then no. Okay, now the next is we are going to select a specific face. Okay. Okay. Okay, so see what happens is that the cross section which we are showing over here. Okay, so the cross section which we are showing over here, when we go to this, okay, and if I define the fixed support, see if I go and select the geometry, see it's not picking. Why? Because this is a superficial geometry which I have assigned, and I cannot pick this point. Okay, see, if I want to apply also, I cannot pick this point. How I'm selecting this face also, still I'm not going to select that component. Why? What is the reason? Because the cross section assigned is superficial. Okay, now how we are going to assign this fixed support? So when you go to this, see the point, it is highlighting this point. See, if I click this point and if I apply it, now the fixed support is acting at this point. Okay, similarly there is one endpoint. See, there is one endpoint here. I am going to apply the load. Okay, here I am going to apply the load. Okay, if I want to change the view, okay, if I want to change the view, how we can do it? See, this is your viewport. Okay, one viewport, two viewport. Okay, so here just check it out how we can represent. These are the views. I want to have a front view. So see, Now I can have the front view. Okay, and you can see if you see the cross section, see how it is. This side the length is higher, right? If I rotate it, see, if I rotate it, okay, the end I have fixed, already fixed, and this end I'm going to apply a load. That means on which direction I'm going to apply the load? I'm going to apply the load on y direction. Okay, that needs to be always understand that on which direction you are applying the load. Okay, so again, now if I go to this view, I'm going to select the front view, right? And now I'm going to pick this point for defining the load. Okay, so I will go to this insert, and then I'm going to define the force which is going to act on this point and the direction. See, if I go to this component, okay, on y direction I want to define the load. Okay, on y direction I want to define the load, and let's say that is 100 Newton. Okay, so once I define the load, see how it is. It is acting on the upward direction, but I want that to be on the downward direction. What I need to do is I need to just define minus 100 Newton. So see, once I press it, see the loading is now on the downward direction. And once the loading is defined, if you click this, see, both the conditions are being clear over here, that how you are applying the load and what are the fixed point. All sort of boundary conditions can be seen over here. You need to again take the screenshot of this geometry, that how the boundary conditions have been applied. Okay, again I will just click the cross section now, so cross section is also over there. Okay, and now if I want to isometric view, so this is the isometric view of the geometry. Okay, see, the load is being acting at the point B and point A is a fixed point. Okay, now I want to find out the total deformation. What is this total deformation? That means X, Y, Z axis complete deformation. Okay, so this is the total deformation I want to observe. The next thing I want to observe is, if I go to the beam result, see, if I go to the beam result, I want to observe the bending moment which has been generated over here. What is the bending moment also I want to observe, because there is a load is acting at the end, and because of that some bending moment is either generating or not, I need to observe. Okay, then in this probe I can find out, I have already defined the total deformation. Then I can define what is the axial forces which are generating. Axial, that means on the axis. Okay, so is there any axis force which is going to be generated over here? Just randomly we are going to pick it. Okay, and there is no torsional moment generated over here. Shear moment diagram, let's just absorb, understand this also. Okay, we are going to understand now. It depends on the loading whether the shear force is going to act or not. Okay, so if I select the path, shear force path, this point and this point. So if I select it, I'm not able to pick these 2 points. Control, you need to press control if you want to pick this. Okay, let me check with this line. Either I can pick this line, vertex, and then apply. No, it's not going to happen. So what you cannot find out the total shear moment. Okay, shear. Okay, so let's now solve this part. Okay, if I solve this, see whether it is going to solve or not, here you can get to know. Okay, as per this is a problem of a beam, so it is going to show you the total deformation, total bending also, and axial force also. If I click this, see, this is the total bending, and if you want to show the movement, how the load is affecting this beam. See, this is how it is affecting the beam. You need to take the screenshot of this geometry also when you are taking your simulations. Okay. I want a word format. I want a detailed report of every single geometry, how you are solving. Each and every step you need to take a screenshot and then make a report. Okay. So this is your total deformation. Similarly, if I want to see the bending, this is the bending diagram. That means maximum bending. At which point maximum bending is happening? Can anybody just tell me at which point maximum bending is going to happen? See, what is this red color indicates? जहां पर बेटा मोमेंट होता है उसके ऑपोजिट डायरेक्शन में बेंडिंग जनरेट होता है, राइट? So that's why at this point the bending is going to be the maximum. Okay, kaise? Force multiplied by the length. So this is having the maximum bending moment at the end. So that's why it is reflecting maximum bending moment at the end. I hope so you all get it, right? Okay, now the axial forces. Axial force तो यहाँ पर constant है, क्यों? क्योंकि x एक्सिस में कोई फोर्स लग ही नहीं रहा है, सिर्फ y एक्सिस में ही फोर्स लग रहा है, राइट? ओके, नाउ लेट्स डू वन चेंज. क्या? अभी अपन x एक्सिस में भी फोर्स लगा के देखते हैं. ओके, so what I'm going to do is I will insert another force which is going to act over here. Okay, I will just remove the cross section. I will just make it to the front view. And now again I will select this point vertex. At this point I am going to select. I am going to select a component in x-axis now. I am going to define the force which is acting at the x-axis. And let's say this is 50 Newton. Okay, let's say this is 50 Newton. Okay, and I will apply. So now 50 Newton force is also acting in it, right? So the two forces are acting in y direction and also in x direction. Okay, now again I need to go and solve it. Now you can find out there is a difference in the solution now. See how it is different. Now I am changing into isometry. Now observe the deflection, how it is going. It is going to be reduced because you are having a actual load also right now. So the earlier deformation and now the deformation which is going to happen over here is going to be reduced. Similarly, the bending. See, now if I allow the bending now, the deformation over here, the 50 Newton force, what is the effect of 50 Newton force? Can be understand over here. Now, similarly, the axial force now. Okay. Okay, so if I observe the axial force now, just hold on for a second.